Hey everyone, and welcome to our explainer today. We are breaking down an absolutely incredible engineering breakthrough from K-Technology USA that is quite literally rethinking how we generate and store power. Specifically, we're diving into the AFG DNA Urban Hybrid Power Platform to make its complex mechanics super easy to understand. This isn't just some tiny incremental update to what we already have. It's a massive architectural shift in energy capture, engineered from the ground up to build perfectly resilient microgrids. So let's kick things off with a simple question. Think about this for a second. What actually happens when the wind stops blowing for just one moment? Or, say, a huge industrial diesel engine has a tiny little stutter in its combustion? Well, in our conventional power grid, even a minor drop in rotational speed causes instantaneous voltage sag, frequency destabilization, and, honestly, a potential total grid collapse. We have built an incredibly advanced world that is completely dependent on electricity, but the underlying system, it's shockingly fragile. To see how this tech fixes that vulnerability, we'll just quickly walk through the grid's fatal flaw, introduce the AFG DNA system, look at the mechanical battery and multi-generator matrix, check out the solid-state storage, and finally wrap up with powering the urban future. Starting off with Section 1, the grid's fatal flaw, that century-old vulnerability. For over 100 years, we've been totally locked into this one engine, one generator mindset. Think of those massive wind turbines or giant diesel generators you see. It's one giant prime mover synced to one massive generator on a single rigid shaft. Sure, it's structurally straightforward, but it carries a massive, massive flaw when we look at real-world reliability. It's the classic single point of failure. Under the old setup, a sudden load spike or a random gust of wind causes a drop in RPM. And if that one giant generator has a short circuit or a mechanical glitch, it halts the entire system. Boom, total blackout. You lose the generator, you lose everything. It's an all-or-nothing game, and it just can't guarantee the continuous, zero-gap power that our modern digital infrastructure absolutely demands. Which brings us nicely to Section 2, introducing AFG DNA. And remember, this is engineering, not magic. I want to be super clear here, because when people hear about wild breakthroughs in energy efficiency, their minds often jump straight to science fiction. But we aren't talking about perpetual motion or breaking the laws of physics. It operates strictly under the first law of thermodynamics. It doesn't create energy out of thin air. Instead, it acts as an ultra-high-efficiency recovery platform. It simply captures the kinetic energy that our legacy systems literally just throw away as friction, heat, and vibration. Think of it like a perfectly coordinated relay race in 4 distinct steps. First, it captures chaotic, messy wind energy. Second, it physically smooths that energy out. Third, it extracts it as electricity. And finally, it vaults that pristine electrical current into next-generation chemical storage. Let's dig into exactly how that happens. Moving to Section 3, the mechanical battery, which is really the heart of the system. Before we even get to electricity, we have to talk about mechanical control. Instead of dealing with fluctuating winds directly, the raw input is fed into a massive centralized flywheel. Imagine a heavy, solid steel hub spinning incredibly fast. It acts like a giant mechanical shock absorber. Because of its massive weight and spinning momentum, it temporarily stores kinetic energy. It literally absorbs sudden wind gusts and bridges the gaps when the wind totally drops, keeping the rotation highly uniform for the generators down the line. And because of that mechanical buffer, the AFG DNA system can use low-profile H rotors to harvest wind in a way we haven't seen before. Standard megawatt-scale turbines need perfect, high-speed wind to even start turning. Otherwise, they just sit there, wasting all that potential energy. But this platform, it loves those chaotic, multi-directional, turbulent microwinds you find bouncing around urban skyscraper rooftops. It just continuously accumulates that tiny bit of torque directly into the heavy flywheel. Okay, on to Section 4, the multi-generator matrix, or smart power extraction. This is the brain of the operation, where that perfectly smoothed mechanical energy becomes electricity. Here's where things get really clever. Instead of relying on one massive, vulnerable generator, the system uses a parallel array of independent axial flux generators, or AFGs. They're all mounted around a common centralized ring gear, so you have multiple smaller generators extracting power simultaneously from that spinning flywheel. The structural superiority here is just undeniable. Legacy systems use this complicated electrical multi-step conversion process that loses tons of energy to heat, but the AFG DNA utilizes direct mechanical coupling. It completely eliminates the single point of failure. If one generator shorts out, the telemetry just isolates it and the rest keep right on spinning. You get a fault-tolerant power supply that just refuses to go down. Plus, what happens when the building doesn't actually need that much power? In an old system, you still have to spin the massive generator, creating massive magnetic drag and heat waste. With this setup, if demand drops, it just electrically disconnects some of those parallel generators, letting them idle with zero drag. The active units stay right in their optimal load zone, maintaining an absolutely wild 96% peak efficiency. Next up, Section 5, perfecting solid-state storage, the chemical vault. Getting the power is only half the battle, right? We have to save it safely and efficiently for a rainy or windless day. If you know anything about renewables, you know the absolute curse of microcycling. Raw wind and solar fluctuate constantly, and sending those rapid, chaotic charging spikes directly into expensive batteries destroys them incredibly fast. But here, because the mechanical flywheel ironed out all those chaotic spikes beforehand, the battery only ever sees perfectly stabilized uniform current. It literally doubles the lifespan of these multi-million-dollar storage systems. And on top of that, they pair this smoothed power with next-generation solid-state batteries instead of traditional lithium-ion. This completely eliminates the terrifying thermal runaway and fire risks. You see, lithium-ion grids are often banned from dense urban areas because of explosion hazards, but solid-state batteries have zero liquid electrolyte. No liquid means no fire, meaning you can safely put this entire power plant right in a subterranean bunker or directly on an apartment rooftop. Finally, wrapping things up with Section 6, powering the urban future with dual-use applications. This incredible blend of mechanical and chemical engineering unlocks some amazing real-world applications. It bridges the gap between rugged military necessity and everyday civilian life. We're talking zero-gap emergency power for high-density apartments, completely blackout-free tactical microgrids for forward-operating military bases, and the ability for smart city developers to finally harvest the messy wind whipping between our skyscrapers. By completely rethinking the architecture of how we spin a generator and store charge, K-Technology USA has created an unshakable foundation for distributed power. It really makes you wonder, if we just stopped wasting the invisible energy swirling right above our heads every single day, just how resilient and independent could our smart cities actually become? Thanks so much for joining me today, and I hope this sparked some curiosity about the incredible engineering powering our future.